Hello guys, welcome to another class on Benco Institute. I am your host Gideon. On today's video, we'll be discussing and teaching how to properly size your solar energy system. And we'll be doing that using the basis of our recent installation where we installed a system for our client for his 2-bedroom apartment. So if you work with me from now to the end of this video, you basically learn how to size a solar energy system for a 2-bedroom apartment, which you can eventually extend to different type of apartments as the case may be. This particular video may come as a surprise to our subscribers. Of course, they may not have seen us shoot videos of solar energy, but let me say this out: beyond YouTube, we are experts in solar installations, and of course we also sell the basic components as regards solar installation. So we are the best person to teach you this particular topic. If you are from this part of the world, you would observe that solar energy systems are basically gaining traction as it stands. By gaining traction, I mean a lot of persons are now delving from regular generators to solar systems, and this is because petrol prices got significant hike recently, and of course because of inflation generally, everybody feels there is need to tap power from the sun, which is free. And of course I am very much in support. If you have the capital to do it, please go ahead and do it. It is the best form of power I can think of. Without wasting much time, let's dive straight into this video and teach you guys how to size the solar system of a 2-bedroom apartment with given loads. So let's go straight to our screen, and from our screen you will have better understanding of everything I will say. So this is it: solar energy system sizing for a 2-bedroom apartment. Like I said earlier, this was done for our clients not too long ago. So you would see in this particular video how we size various components and how it eventually gave us a powerful solar system. Okay, so let's walk in. Like it says here, sizing the solar energy system involves determining the appropriate capacity of solar panels, inverters, battery, charge controllers, and basically other components that you need in that system. Okay, you will also take into consideration available sunlight. Don't worry, we'll talk about that in details. Now, in this particular video, these are the components we are going to size. Okay, we are going to size the PV array, the battery bank, we are sizing the inverter, and we are sizing the charge controller. Forget about these names, they may look bogus, but they are actually simple. I will try my possible best to break them down so you have an understanding of the names. Okay, they are new names to you if you are not into solar system, but get me right, they are not difficult to understand. Some people would ask, what is a PV array? A PV array or a photovoltaic array. Okay, this is a collection of solar panels. For those of you who have this system, you probably hung yours on top of your roof. For those who don't have this system, you've probably seen people who hung theirs on top of their roof, just flat or stick on top of their roof as the case may be, and they may be multiples. Okay, so when they are more than one, it is called an array, but when it's just one, it is called a PV panel or a PV solar panel. As whatever it is, that is what it means. It's just one, it's called a panel. When it's multiple, it's called an array. I hope we are getting something clear here. And this is what collects the solar energy from the sun. Okay, for those of you that have happened to walk on top of a roof and you are seeing this solar panel, what it does is that it extracts or it collects. It's more like will I say a drum that collects water. Okay, the water is the source, water enters the drum. That is how these PV panels work. It collects sun enters the panel. Okay, I hope that is understood. And then what we have next is the battery bank. The battery bank. The battery bank is what stores what this solar panel collects. Okay, a battery bank could be just one battery, it could be more than one battery, and on and on and on like that. Okay, so battery bank basically is a collection of multiple batteries connected together in series and in parallel to store electrical energy. The electrical energy that comes from the PV array, it just goes straight to the battery bank. Okay, hope we are getting something clear. Yeah, okay, it's more like your phone that has a battery and stores after you charge it, it stores for a while, and then you can use it for a long time before it dies down, similar to how the battery bank functions in the solar system. Mind you, the PV array system brings DC power, DC voltage. Okay, so I hope we're clear with that. Up next is the inverter. The inverter converts the DC energy that goes into the battery into AC, because you would agree with me that our household, just like this lighting point up here, uses AC currents, AC, alternating current. Okay, just like the fan in front of me, it uses AC. Okay, so a lot of our appliances at home uses AC, so there is need to get something that will convert that DC energy in the battery to AC energy, and that is where the inverter comes into play. And then we have the charge controller. The charge controller, like the name implies, you would basically tell that this helps in controlling charging of the battery. This is what controls how to charge the battery, and when the battery is charged to a particular extent, this is what also tells the system to cut off power to the battery and to just stop charging the battery. Basically, that is how the charge controller works. Those are just theoretical explanations. Of course, you can get those information anywhere. But what we'll be doing next is where the meat of this video is. This is where you have to learn a lot, and please stay with me. So while creating a system for your house, be it a 3-bedroom apartment, a 4-bedroom apartment, a bungalow, duplex, or even a 1-bedroom apartment, or perhaps you just want to create a system for 3 appliances, what you take into consideration is your load. And of course, we'll call that load assessment. In load assessment, we list out all our household appliances. We factor out our essential load. By this statement, I mean we factor out the load that we'll be needing in the house, because there is no need of factoring out some loads that are not necessary, because you would have to spend more in creating a system that can power all the loads. Remember, I said creating a solar system, installation of a solar system is capital intensive. So wisdom demands that you reduce your load such that you spend less money on creating a system. Work with me. You factor out your essential load, you know the power rating of this load. You can easily know the power rating of your load by looking at the nameplate. Let's say for a refrigerator, you can know this by looking at the side or the back of the refrigerator. You see where it is written, power is this, voltage is this, current is this, and on and on. Then your number of each load. Okay, if you are using 5 fans in your apartment, take cognizance of it. Write it out. I'm using 5 fans. If I'm using 13 lighting points, you take cognizance of it, you write it out. I'm using 13 lighting points. And of course, the last one, you look at the duration per hour of each load. So this is basically what load assessment means. If you don't properly size or assess your load, you would at the end of the day give a wrong sizing for your solar system, and that in fact will hurt you. If you are doing this as the owner of the house, it will hurt you. If you are doing this as a solar technician or a solar engineer, you will lose your job or you lose your client, as the case may be. Then for these 2-bedroom apartments, these are some of the appliances we have. Okay, remember I said we are sizing a solar system for a 2-bedroom apartment. So for these 2-bedroom apartments, these are equipments or loads or appliances, as the case may be, that we have. We have refrigerators, we have television set, we have washing machine, we have fans, we have laptop, we have pumping machine, we have water heater, we have electric cooker, we have blender, we have pressing iron, and we have bulbs. What I did there was to take cognizance of all the loads in the house. Okay, take cognizance of all the load. Like I said earlier, list out all load appliances. Okay, then next up, we factor out the essential loads. What load are you using regularly? What load you can't do without? Are there some loads you can do without for some days, and then when power comes from the grid, you are able to use those loads? If yes, we take that load out. Are there some loads that if we add to this system, it will increase the capital we'll be spending on this system by significant margin? We take that out. Are there some loads that you don't really need them at all? They are just there for the sake of being there. If you were to get a generator, perhaps you will power those loads, but because we are trying to cut down costs and reduce capital, you won't power it. So that is where we end up stating the essential loads. And what we did here was we got the television sets, the refrigerators. This is supposed to be a refrigerator. They have just one refrigerator in the apartment. We have the washing machine, fans, laptops, and bulbs. Of course, television sets, the kids needs to watch TV when they are back from school, or you, as the head of the house, the man of the house, would want to watch news to see happenings around the world. Refrigerator, at least to keep your foodstuff safe and you get so it doesn't spoil. And washing machine, you could put on your washing machine for an hour a day just to wash some clothes. This is quite important. Of course, your fans are very important. If you don't on your fans, I honestly don't know what you need light for. Then your laptop. Personally, I use laptop every day. And of course, your bulb, very essential. You see, we factor out 1, 2, 3, 4, 5, 6, just 6 essential loads, and instead of about 12 loads here. Okay, we factor out 6 essential loads. These are loads that the family or the apartment cannot do without. So we now need to know the power rating of this load and the number of each load, and then that is where we have the load assessment table. Okay, you have to create a load assessment table. This load assessment table is going to help you in sizing so many things. Okay, without this load assessment table, you can't do anything as regards solar system installation. You can't know what to do. So this load assessment table is highly necessary. So that is why sometimes some of my clients, especially I'm domiciled in Warri, right? Warri Delta State, and I could have clients in, let's say, Lagos, or let's say Akwa Ibom, like the recent job we did in Akwa Ibom. Then they'll call us, Benco, I have a 4-bedroom apartment. What solar energy system do I use? Or please just give me the cost of the system you'll be installing for me. That is the wrong question to ask, because you could have a 4-bedroom apartment and you could have load of the 1-bedroom apartment. You get me? You could also have a 4-bedroom apartment and you could have load like that of a warehouse. So how do you expect me to give you an estimation of the solar energy system you'll be needing? Of course I can't do that. The only thing I will ask you now is this: what are the loads do you have in your house? Simple question. What are the loads do you have in your house? And please brief me. On my WhatsApp, I've had a lot of people who, even as regards generators, I'll tell you, brief me the loads you have in your house. This will enable me size a system for you. Okay, that is how it works. So let's look at the load assessment table. Remember, we're looking at bulbs, fans, laptops, and the rest, and we sized everything here. Okay, I also had to add home theater system and miscellaneous. Miscellaneous is basically just in case there's an external load that was not factored in, this system can still pick it up. So when I create a system, I always make sure I kind of oversize it by 30%. Subconsciously, that is what I do in my head, even down to generators. When I'm sizing a generator for a client, I size it an extra 30%. That gives the system leverage. Okay, so let's go. We have our light bulbs, 9 watts. We have our LED TV, 100 watts. We have our refrigerator, 225 watts, washing machine, fans, laptops, home theater system, and of course the miscellaneous I talked about. We have our appliances on column 1, power on column 2, quantity of the appliances on column 3, just like I stated earlier. We have the total power on column 4, duration on column 5, and of course total energy on column 6. Light bulbs, 9 watts. Okay, quantity 13. When you multiply this 13 by 9, we have 117. That also applies with 100 by 2, 200, 225 by 1, and on till we get to the miscellaneous, where we multiply the miscellaneous by one quantity. We have fans, 3 fans in the apartment, 1 in the sitting room, living room, 2 in the bedrooms. That's one in each bedroom plus 1 in the sitting room or living room, and that makes it 3. Total power for that is 195. So basically what we do is to multiply power by quantity and we'll get total power. But that is not all. How many hours will this system be, will these appliances be used? Remember, I said that here, duration per hour of each load at the bottom here, duration per hour of each load. So how many hours will this be used? Remember, again, we are trying to size a system that is not too expensive. Of course, we know solar energy systems are expensive, but we're trying our best to size a system that is not too expensive, owing to the fact that we still believe power is coming from the grid. Okay, this is not a 24-hour system. If it was a 24-hour system, it's going to be gigantic. This is not a 24-hour system because we are connected to the grid as well. This apartment is connected to the grid. This apartment also have a generator. I sold the generator to them. So they also have a generator, a petrol generator, and they are connected to the grid. But they want a situation where most times they are on solar so they can reduce cost on petrol. Okay? I hope you are getting this. So this is not a 24-hour system. If it was a 24-hour system, all duration here would have been 24 hours. Or for some, probably 18 hours. But you get the point. It would have had a higher hour duration here. So for the light bulbs, we want it on for 7 hours. For the LED TV, we want it on for 5 hours. Likewise, the refrigerator, the washing machine, our fans. We wash our fans for 8 hours, laptop for 3 hours. We just want to charge it, and then after charging, we unplug. Sometimes we can be charging and using as the case may be. Then we have our home theater system, which is just 40 watts, and we'll be using it for 6 hours. And then we have miscellaneous for 3 hours. Okay, miscellaneous is to help the system just in case you add an extra load that you are not in the of. So when you multiply total power by the duration, which is the hours, it gives you the energy of the system, total energy of the system. 117 by 7 will give you 819. You can use your calculator to confirm this figure. 200 times 5 will give you 1000 watt hour. Okay, 225 times 6, 1350. 195 times 8 will give you 1560. 203, 600, and on like that. So we'll go to miscellaneous again, where it gives us total watt hour as 450. So if we do a summation of the total watt hour, what do we get? We have 6269 watt hour. So we are using a total energy of 6269 watt hour a day. Okay, and then total power of course is 1337 watts. That is the total power of all the loads we are using today. Okay, that said, we move on to sizing solar PV panels. Remember these figures please, because we'll be needing them subsequently. Remember this figure, the total energy of 6269. Okay, just remember it. Very important figure. We'll be using it as we proceed. Up next, we are looking at sizing the solar PV panels. Sizing the solar PV panels. I'm trying to be very fast with this, so the video is a little bit short. I hope it is short actually. But if it's not, please, you have to watch it. There's great knowledge in this video. And by the way, if you are new to this channel and you still haven't subscribed, I honestly do not know what you're waiting for. Please do well to subscribe and turn on the notification bell, so when other very impressive videos like this are being posted, you are among the first to see them. Okay, share this link to family and friends as well. I think they will need it. While sizing solar PV panels, there are two values you take note of. You have to take note of these values. Remember I said take note of this particular value while I was in the last slide, and that is your daily energy consumption, which was at 6269 watt-hour. And of course, another factor to consider is your sun peak hours. Sun peak hours is the number of hours that the sun is at its peak. Okay, I'm trying to explain that beautifully well so you understand. You know, there are sometimes you are in the sun, and you don't really feel the intensity of the sun, especially early in the morning. You don't feel the intensity, but from times like 11:30 to around 5:30 or 4, as the case may be, there is a high intensity of the sun. Okay, so that is what we call the sun peak hours. In this part of the world, the sun peak hours is usually 5 hours and 6 hours, but I decided to pick 5 hours because I want to size a system that is very efficient. So depending on which part of the world you are, you can simply go on Google and confirm for yourself the sun peak hours of your particular location. I think Kenya, Nairobi is 5 hours. I'm pretty sure of that. I have a friend in Nairobi and he told me some time ago that the sun peak hours for a particular location is about 5 hours. I think Tanzania is 6 hours. I think on and on different locations, but this particular location 5 to 6 hours. I decided to pick 5 hours. So how do we get the rating of the solar panels we put on our roof? And that is where this formula comes into play. PV panel array ratings equals to daily consumption over sun peak hour times 1.3. 1.3 is to compensate for losses, because you could have a system that has a particular rating, but before it gets down to your battery bank or before it gets into your apartment, it has lost some power along the line because of the length it has to walk down to your apartment. Okay, hope you are getting it. It's just like I have a particular energy at this point in time. Before I walk down to the junction of this street, I would have expended little energy. That is not to say I will be totally down, but I may have lost some energy here and there, little. Okay, that is what applies to this as well. So we use the 1.3 as a safety factor to compensate for the losses. So the daily consumption is 6269, right? 6269, and the sun peak hours is 5 hours. Okay, so if we do the calculation, we would get 1629.94 watts. So our entire PV array system on our roof or anywhere we are putting it at that particular point in time is 1629.94 watts. Okay, if we approximate this, we should be getting 1630 watts. I and my team will pick a 450 watt panel for our client. Okay, you can see it here, 450 watt panel. You can see it on the nameplate. Okay, next up, how many number of PV panels will be needing? We now know the total number, the total rating of our PV array system, right? But what we don't know now is how many panels we'll be needing. But we have already picked 450 watts panel, that is one. So how many do we need to combine to give us 1639.94 watts? And it's that simple. Load of PV panel equals to total PV rating or total PV array rating over power of PV panel. And so we have 1629.94 watts over 450 watts. That gives us approximately 3.622 panels, which if you approximate it, it will give us 4 panels. But personally, like I said, depend on how the clients wants the project to look like. Some clients will tell you, this is what I want, this is what I want. It's now left for you to factor it out yourself. If I increase this, it will help me in achieving this. So for that, I personally increase to 6 panels. I can use these 4 panels, good and fine. The system will work perfectly well, but I personally increase it to 6 panels just for some days where the sun rays is not of high intensity. The extra 2 panels will compensate for that. Okay, next up is sizing our battery bank. So what we've done now, we've sized our PV array, and what we'll be doing now is sizing our battery bank. Sizing our battery bank is not difficult, I must say, but a lot of persons really do not know how to do it. These are some of the factors you should consider while sizing a battery bank system. We look at that factor again, total energy consumption, which is 6269 watt hour. We look at depth of discharge of the battery. We look at battery efficiency. We look at system voltage. We look at days of autonomy. Okay, let me explain that days of autonomy. Days of autonomy is the amount of days you can go even if there's no sun ray. Okay, in other cases, it's the amount of days you can have power with you can have power in your apartment even if there is no sun ray or there's no power from the grid. It depends on how you look at it. So days of autonomy basically means your house should be powered even if there's no external sun ray or there's no power from the grid. Are we good? So that is what days of autonomy means. And this system voltage, it's another key thing to understand, but you will get that better in the next slide. So for this system, we are looking at this value, 669 watt hour. Depth of discharge for this battery is 50%. Okay, this is how far the battery can discharge. Okay, we have battery efficiency, how efficient the battery is, and this is 85%. System voltage is 24 volts, and days of autonomy is 1. Okay, days of autonomy is 1, and this simply means we are expecting power from the grid. If there is no power in our apartment, we can get power from the grid, or we can put on our generator. So that is what days of autonomy for this particular sizing means. Okay, you can go on Google and get better understanding of what that means. Okay, for some systems I can use days of autonomy as 3. There's a system we'll be working on in Port Harcourt later this month. Later this month we could give days of autonomy as 3 because the client really wants to go off grid and doesn't want to use generator, so we can give days of autonomy as 3. This, in fact, if there is no sun ray for 2 days, the system will still be on. The system will still be working and you still have power in your house. So that is it. So guidelines for system voltage. Remember I talked about system voltage here, which is 24 volts. There are guidelines for system voltage. And the guidelines for system voltage is installations that are less than 1200 watts. We use 12 volts for them. So we have a 12 volts system voltage for installation less than 1200 watts. Medium installation, these are installations ranging from 1200 watts to 3000 watts, and we have a system voltage of 24 volts. Large installations, greater than 3000 watts, we have 48 volts, and on and on and on like that. So for this particular system, it lies between 1200 watts and 3000 watts. Okay, that is it. So we're using a 24 volt system for this. So this is the formula for a battery bank capacity. Remember, I said everything has a formula. Everything has a formula. Okay, this is daily consumption over depth of discharge times efficiency times system voltage in bracket times days of autonomy. So after this calculation, 6269 daily energy consumption, 50%, 50 over 100 is 0.5, efficiency 85%, 85 over 100 is 0.85, system voltage 24 times, all in bracket times 1. So this is what we have. Our battery bank capacity is 615 amp hour. So what we need is a battery bank of 615 amp hour at 24 volts. Okay, mistakes with this and above at 24 volts. We need a battery bank of 615 amp hour at 24 volts. You see, these are different jobs I've done over time. I've done jobs with luminous tubular battery, and then this job we did now for this 2-bedroom apartment was with this lead acid battery, 6 volts 400 amp. Then I'm going to explain something as regards batteries for you guys, because if I don't, it's going to confuse you guys. I've had to teach someone something related to this, and it took me minutes to explain before I found a better way to explain it. So I will just go straight to the board now, and I will teach you how to basically get a battery bank of this 650 amp. Because on a norm, if we are to get a battery bank, we'll just go to the market. I need a battery bank, I need a battery of 650 amp, and probably I always like something higher, so I will go with maybe 650 amp hour. I need something of 650 amp hour at 224 volts. My dear, I tell you, you won't see it, or rather I have not seen it. It's possible you will see it it's very possible you may see it, but I have not seen it. So in absence of this, we have to combine different batteries to give us this. So let's go straight to the board so we understand better what we are talking about. So guys, this is what we need. We need a 24 volt 615 amp hour battery. Okay, this is what we need, right? So before I come here and teach you how to combine batteries to give you this, I will basically explain to you so you have an idea how batteries work. Okay, so in combination of batteries, there are two methods. It's either you combine a battery in series or you combine a battery in parallel. And now these are two batteries, right? We have plus here, we have minus here, and we have another battery here. We have plus here, we have minus here. Okay, let's say this is a 2 volt battery at 20 amp hour, and let's say this is another 2 volt battery at 20 amp hour. Okay, if we are to combine these two batteries to form a battery bank, and we are to do it in series, this is what we have. We have this to this, right? And then we have something like this, something like this. So we've combined this battery, positive to negative. What we've done now is we've combined the battery in series. And when you combine the battery in series, what happens? When you combine the battery in series, this is what happens. Voltage increases. So here, this plus this gives us 4 volts and 20 amp hour. Do you understand? So what it means now is if we combine two batteries in series, we have an increase in voltage. So we have 4 volts and we have 20 amp hour. Now what happens if we combine two batteries in parallel? Now this is a battery plus minus, another battery plus minus. Okay, same rating, 2V 20 amp hour, 2V 20 amp hour, same rating. Now remember, for the series we used minus and plus and minus, difference in polarity. Okay, that is how we connected it. But for this is not how we do it. That's not how we do it. We use the same polarity. So this is how we combine a parallel battery, plus to plus, minus to minus. Okay, so but for a battery system that is combined in parallel, what do we have? Instead of having 4 volts and 20 amp hour, what we now have is we have 2 volts and 40 amp hour. Okay, do you understand? So that is what we have for a battery combined in parallel, and this is what we have for a battery combined in series. Remember, I'm teaching you guys this because we will be needing it here. Okay, now we've gone to the market and then we checked around what battery do we need for a system that will give us, what battery can we combine to give us 650 amp hour and 24 volts. Then our two batteries we came up with, or the batteries we saw that we can combine, is this. We have a 400, we have a 6 volt 400 amp hour battery, and then we have another battery of 12 volts 220 amp hour tubular battery. This is lead acid battery, tubular battery. So these are the two different batteries we have. Remember, the reason we are combining again is to have what? Is to have this. So if we have, I need to erase this now. Hope you jotted this down. If you did, good and fine. If you haven't, please scroll back to the video and jot it down. So this is what this is the batteries we went to the market and we found. Okay, personally for me, I don't do all this calculation because I just need to brainstorm. In minutes I can sum everything up in my head, but for your sake I'll be doing this calculation. So we have this battery which is plus and minus. We have a 6 volt 400 amp hour. Okay, if we want to get 24 volts, what do we need? Yes, you are very correct. We need this in series, 4 batteries of this in series. So we have plus minus, 6 volts, blah 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 blah. So because I've already told you that when all these are in series, okay, I've already told you that when all these are in series, what we have is an increase in voltage. So what we have here is 24 volts 400 amp hour. Do we understand? But have we gotten this? We haven't gotten this because this is way less than this. So this is what it has given us. This is what it has given us. 24 volts 400 amp hour. So this whole system, this is what we got with this whole system. Now we can duplicate this times 2. Okay, or rather maybe that I don't want that to confuse anybody. I honestly don't want that to confuse anybody. And so what we've just done now is we have this and we have this. We have 24 volts ampere, 24 volts 400 amp hour. Now we can decide to do this system again. Let me just do it again so it's easy to understand. Plus minus, plus minus, plus minus, plus minus. This. Okay, so what we now have here again is 24 volts 400 amp hour. Okay, that is what we have with this 24 volt 400 amp and 24 volt 400 amp hour. We've connected this in series. So we have 8 batteries already, 4 in series, another 4 in series, to give us 2 different batteries of 24 volt and 400 amp hour. And of course, what do we do next? We combine this. This is plus, remember, this is plus, minus. We're now combine this in parallel, okay, where the polarity is the same. Remember, for series the polarity is not the same. So what we've done now, we now have a 24 volt system and 800 amp hour. Okay, easy peasy, right? But if, let's say, we want to do it with this system, let's say we want to do it with this battery rather. Remember, this is eventually the system we use for our clients. This is what we use for our clients: 24 volt 800 amp hour, very powerful, way more than 650 amps. So this can even charge battery for so long. And of course, remember the statement I made that I usually oversize a little so my clients in the long run can be happy. That is what we did with this. So we can equally try to do this, but then again we will have just 4 batteries for this. This is 12 220, 12 220. 12 plus 12 is 24. So we already have for this plus minus. Oh, sorry. This connected to this and this up, this up. So we already have, what we have here now is a 12 volt 440 amp. Well, we do the other one just like we did here. We'll have another 12 volts 440 amp. So when we combine in parallel, we have 24 volts 440 amp hour. Okay, this is not sufficient enough for our system. However, that is not to say we can't use this one. We can use this and it will work very fine. But then from our calculation, this best fits our calculation. Are we good? I hope we understand. If you don't understand and you are part of our community, please send me a direct message. I will explain better. But I'm very sure with this explanation, you should understand. Okay, so basically for this system now, for this battery bank of 24 volts 615 amp hour, we need 8 batteries. Okay, we need 8 batteries of 6 volt 400 amp hour. Are you getting me? For this system, we need 8 batteries of 6 volt 400 amp hour, where 4 of these batteries are connected in series. 4 connected in series, and of course we now have 2 strings, and these 2 strings are connected in parallel. Is that understood? 4 battery connected in series, and of course we have 2 strings, a complete series. Okay, probably I didn't make mention of that. If a battery is connected in series 1 2 3 4, it is called a string. If another battery is connected in series, it is called a string. Another battery is connected in series, it is called a string, and on like that. Anything connected in series, it is called a string. So we have 4 batteries in series and we have 2 strings. So these 4 batteries are connected in series, and of course they are now stringed together in parallel. So therefore, we use this battery, this 6 volt 400 amp hour battery, instead of this luminous 220 amp hour battery. And then we will be needing 8 pieces of 6 volt 400 amp battery, 2 strings of 4 batteries in series, just like I've explained. Alright, next up is inverter sizing. Inverter sizing. You see, this is that system that helps in converting the DC from the solar panel to AC, which will be needed in our house. Okay, but sizing it is not difficult, but yet it's something you have to take some factors. You have to consider some factors, and some of these factors you consider is motorized load. Okay, always consider the starting and running power requirement of motorized loads like pumps, compressors, to ensure inverter can handle their peak demands. Okay, inverters should be sized to accommodate both the continuous power draw and the surge current. Do you realize that if you are using your generator, your regular power backup generators at home, and then you switch on your freezer or your fridge, the generator changes in sounds, then eventually balance up. That first change in sound has drawn it. That first change in sound happened because the refrigerator used its peak power before it balances up. There's always a peak power, and that peak power draws more current. Okay, so you have to factor that when sizing an inverter as well. Okay, so make sure you look at the peak of the motorized load while factoring. We did all that. So you see it. So properly sizing the inverter for motorized maintains efficiency and prolongs the lifespan of the inverter. So let's look at a table we did putting into consideration motorized load. So we have this is our format table. What we just changed was removing the amount of hour and the total energy. So we have light bulbs, LED, TV, refrigerator, washing machine, fans, on and on. These are the total power, nothing has changed, and this is what we got here. But then we have to factor in motorized load, like I always said, and that is where we did some small mathematics of multiplication. Okay, to account for source power, motorized loads are multiplied by 3, laptop by 2, and other regular loads by 1. Other regular loads include the light bulbs, home system, inverter system, and miscellaneous. Okay, so we multiply the light bulb by 1, refrigerator by 3, okay, washing machine by 3, fans by 3, laptops by 2. My laptop has source power. When you plug it in, you will realize how much current it draws. So everything we got here is 2,937 watts. That is less than 3,000 watts. But how do we choose an inverter system? We choose an inverter system that is higher than what we calculated here. I told my clients to go for a 5 kVA inverter because it gives you opportunity to grow. Okay, that is another teaching for another day. It's something I'm going to teach another day, but just know the higher the system, it gives you opportunity to grow. It gives you opportunity to increase your panel, your batteries, as the case may be subsequently. But unfortunately, my client was not too buoyant enough, and we settled with 3.5 kilowatt inverter. And the 3.5 kilowatt inverter is still way more than the total power. So make sure any inverter you choose is way more than your total power after considering your surge power for motorized loads. So we went with a Choice Solar. This Choice Solar has 3.5 kVA, with 3.5 kVA inverter, 24 volts, and pure sine wave inverter. However, this is what I actually wanted. I needed a grow volt inverter system. That was what I needed, but unfortunately at that point in time I couldn't get grow volt, and I settled for Choice. That is not to say Choice is not good. Choice is equally very good. I've used it several times, but I just have some likeness for grow volt. I honestly don't know why I like them, but I actually do like them. So next up, which happens to be the last, is the charge controller sizing. Please, while we are here, make sure you listen attentively, because a lot of persons don't know this, even down to your technicians. They just choose a controller, a solar charge controller, without knowing why they are choosing it, or because they've done previous jobs before. They just feel this charge controller should be able to power or should be necessary for the next job they are taking, even if the ratings or the household appliances are different. So, but with what I'm going to teach you guys now, you will have a strong understanding of this. Okay, remember our PV panel, individual PV panels were 450 watts, right? And VOC short circuit voltage, the open circuit voltage is 44.22 volts, and the ISC is, with the short circuit current, is 12.38. These are the only values we need to basically size the charge controller. But then these are the different steps we take while sizing the charge controller. The charge controller should work in line with the system voltage. Our system voltage is 24 volts, right? The charge controller should work in line with the system voltage. The total voltage of the PV panels in series must not exceed the maximum input voltage of the controller. Okay, and then the total current is strings. Remember, a string is for batteries. I did explain something with batteries, that a string is batteries connected in series. That's a string. Another battery connected in series, another string. So for those 8 batteries, we have 2 strings, 4 in parallel, 4 in series, 4 in series. So same applies to string here. For panel, for other things, that's how string is explained. Okay, so we went with an MPPT solar charge, a Schneider MPPT solar charge controller. Schneider. Okay, this is a reputable company. We went with this. Getting this was a little bit not okay. Another job, so I will probably use Felicity, just like I stated here. Let's go back. I'll probably use Felicity, but our clients had access to this charge controller, and luckily for us, it worked perfectly. We already know the charge controller should work in line with the system voltage, and ours will basically work in line with this system voltage: 12, 24, 36, and 48. Total voltage of panel series should not exceed input voltage of the controller. The total current in strings must not be higher than the input current of the charge controller. Okay, so we have to do that so we don't destroy the charge controller, and that is where we did small mathematics. Okay, remember system voltage, the first criteria, done and dusted. The maximum input voltage of this charge controller, of this Schneider charge controller, is 150 volts, which is pretty high. The maximum input current is 100 amps, which is fantastically okay. So therefore, the total VOC, which is open circuit voltage, is low of panels in series than VOC, which is for each panel. The VOC for each panel is 44.2 times 1.3. 1.3 is the safety factor. I've always used the safety factor, right? So the number of panels in series, what we now did now was to combine two panels in series. Maybe we should go to the board so I explain that again, all right, so you understand better what I did. So what we did with this system was to combine all the panels. Well, combine two panels in series, 2 panels in series. So this is what we'll find on our roof. Okay, this is plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. These are 6 different panels, and we had to, because of the charge controller we're choosing, there was need to do a particular arrangement that would not exceed the total input voltage and then the total input current. So what we did here was this: we combine this in series, okay, and then we'll combine this in series again, okay, and then we'll combine this in series again, okay. So what we have now is 3 strings: 1 string, 2 string, and 3 string. So what we did now was to parallel everything, okay, was to parallel everything. So this is our solar array, this is our PV solar array. Okay, so this is what you find on our roof. I repeat, 2 in series, 2 in series, 2 in series, making it 3 different strings, and you have to parallel 3 different strings. Remember, for parallel, all polarity is same. For the negative side of polarity is same as well. So what we now did now, the total VOC for the low panel series times VOC times 1.3, we got this, which is 114.92 volts, which is less than our maximum input voltage of 150 volts. Okay, and then we got 50 amps, which is less than our maximum input current of 100 amps. So with this charge controller, our system even has opportunity to grow. We can increase the string from 3 to 4, and it will still be less than 100 amps. But one thing we must not do is to touch the total, is to increase the panels in series. So guys, that is it for the charge controller. A project I did before this, we used a Felicity charge controller, and this Felicity charge controller has maximum input voltage of 145 volts and current of 60 amps. It would have equally worked. So this is the system after every done and dusted. This is the system we have. We couldn't get a proper rack, the battery rack to accommodate this battery, and we did a makeshift rack, which was pretty good as well. We just, at this point, we are still installing. Albeit the house now has electricity. At this point, we are still putting finishing touches. Okay, so you will realize from the setting. And so that is it, guys. Thanks for watching. I know you should be able to size any solar energy system in the world if you really understand what we've done with this video. If you are new to this channel, please do well to subscribe, do well to like, do well to turn on the notification bell, so when other videos are posted, you are among the first to see them. We will be posting more of this content. I assure you, we have a lot of content in the work. We have a lot of contents in the work. We have contents with different shots that we have not yet uploaded. You'll be seeing them soon. And then to see them, make sure you subscribe. And if you want to be part of our community, you do well to click on the join button under this video. You will be part of our community. Another thing you can do is to patronize us. We sell generators, the very best of generators. Most of you, some clients here, some viewers here, subscribers here have become regular clients of our firm. So you are rest assured you are getting the best quality. We get directly from distributors at affordable prices. And then if you need a solar energy system installed in your household, in your farm, in your factory, wherever it is, just write us a message. We'll drop our WhatsApp contact on this video. Till we meet in our next live, guys, it's goodbye from us. Take care, stay safe, see ya.